Good morning. So today we're going to look at infinite geometric series. Um, so we still do have our quiz tomorrow. I'll be there tomorrow. Fingers crossed. And the plan then is just to review for a little bit before, take the quiz, and then hopefully start the lesson. So today we're going to look at infinite geometric series. So take a second and see what you notice about using your calculator to evaluate these series. I'll help you with the first one, like to get it on your calculator. So if you go to the math button and then go down, go down. There we go. And then go to the summation. Oh no, where'd it go? So go to the summation. One more, I think. And then you can put this in. So we can put in, let's just put in X. We'll put in that as a 1. In the top part, we're going to go to 4. And then over here, we can do 2. Or you can't see that, but 2 to the X power. So remember that this variable inside of here and that starting, that index down there, have got to be equal to each other. So that one's going to be 30. And then you can do second entry, and it pulls that back up. And all we're doing is just going to change the top part, the bound. I think it's going so slow this morning. So we're going this to 10. Okay. Alright, so then this next one. Just going to go to 20. So we get 2,097,150. Okay, so take a minute and try to finish the two other ones here with those values. So this one is 30. This one is 4696? No, I can't remember. 2046. And this one was 2,097,150. Alright, take a second and fill in the rest. So for B and C, and type those in your calculator for me and try to calculate those. Okay, so I went ahead and calculated the rest. So for B, I got, for the first one, I got a 7.5. For the second one, 7.992. For the third one, I got a 7.99992. For this third one over here, I got 24, 120, and 440. Okay, so let's go back and let's look at what's happening here. So let's kind of compare all three. Now, so for the first one, does the sum to infinity. So this goes, if I get larger and larger and larger and larger and larger, am I going to be able to calculate this value? Like, does it approach a number, I guess? What is happening? I am like blowing up each time here. So I'm getting bigger and bigger and bigger and bigger. So this one is not going to exist because I'm not going to be able to calculate that sum because that's not going to, it's going to go to infinity. Like I'm not going to be able like to calculate. It's not going to be a finite value. Let's look at the difference between A and B. What happens here? I go 7.5, 7.992, 7.9999992. So is this going to exist to infinity? So if you notice, what is it getting closer and closer and closer to? It's getting closer and closer to 8. So it looks like it's maybe approaching some asymptote. Thinking back to your graph of your geometric graph here. All right, so what about this one? So this one, 24, 120, 440. So is this going to exist? Like, am I going to be able to calculate this? No, it's not approaching. It's getting bigger and bigger and bigger. So I'm not going to be able to calculate that. So why do you think, or how do you know that I'm going to be able to calculate these? Like, when would I be able to calculate these? So first, let's look at the types of series that I'm looking at. This first one is geometric. The second one is also geometric, right? So what about this one here? This one is what? Arithmetic. So converge is something that's converging to a number. So it's going down to a number. So how do I know that this is the only one? So it's different. So it first has to be geometric, right? So because arithmetic is going to continue to get bigger and bigger and bigger. But geometric, what's the difference between A and B to be able to calculate one at an infinite series? What do you notice about your R value? This R value is a whole number and this one's a fraction. So, the R has got to, so it's got to be geometric. And its R value, or I guess the absolute value of the R value it's got to be between 0 and 1. Okay. All right. So how we calculate it, the sum here, we can just kind of hypothetically say, right now that this one was going to 8, right? Because it was getting closer and closer to 8 value there. So let's talk about the sum of a geometric series that we did yesterday. Okay, so this is what my calculation is. So as I get to n right here, so if I go to infinity here, so that's going to go to 0. So as your r or your n gets bigger and bigger and bigger, your r to the n power is going to go to 0. Okay. Since your r value, so since your r is less than 1. So if that goes to 0, then in this formula, I'm going to be left with a sub 1, 1 minus 0, all over 1 minus r. So that really just turns into a sub 1 all over 1 minus an r. So let's calculate that second one there then. So let's calculate that second one using this kind of notation here. So what's my first term here? So my first term, if I plug in a 1, that'll be 1/2, right? So 1/2 to the 0 power, which is just a 1. So my first term there is going to be a 1. I mean 4, I'm sorry. Oh my gosh. And then your r value is a 1/2. So your r value is a 1/2. So to calculate the infinite sum here, for this one, we'll say 4 over 1 minus a 1/2. Okay. And I will be looking, this is how you would calculate this. So this is 1 minus a 1/2 is still a 1/2 fractions. So that'll be what, 4 times 2 over 1, which is 8. Good. All right. So let's look here. So the formula for an infinite geometric series is going to be that it's got to be geometric, right? So it's got to be geometric, and your r value has got to be between 0 and 1, so it's got to be a fraction. Okay. And this is where it converges. So if it doesn't converge, then it's going to diverge. So it's going to diverge if the r value is greater than 1, or if it's an arithmetic series. Okay, so it's going to diverge that way. So we can't calculate it if it diverges. Okay, we can only calculate it when it converges. Okay, so this one's going to converge, or how you calculate the infinite geometric series is that it's got to converge. So when it's going to infinity, we'll take the first term and then we'll divide it by 1 minus your r. Okay. All right, so take a second and try to answer these 5 questions for me. All right, so let's check to see how we did. So the first one is I can't calculate it because it is arithmetic, so it's increasing by 5 each time. The second one, I can't calculate it because it is geometric, but it is has an r value of 2, so that's greater than 1, so I can't calculate it there. But what about 3 and 4? So 3 and 4 I can calculate. So what's happening here? So as I go along, the r value here is 1/2, so I can calculate that infinite series there. So the first term is a 2 and the r value is a 1/2. So when you calculate it, then you're going to say your a sub 1 over 1 minus your r value. So 1 minus 1/2 is a 1/2, so then 2 over 1/2 gives you a 4. So the sum there, so this one is going to converge to 4. All right, for 4, the R value, the absolute value of the R value, because this one's negative, right? So it's going to be multiplied by negative. So the R value technically is a negative 1/4 for the fourth one there. But here, when we calculate it to figure out if it converges or diverges, we always talk about like the absolute value. So the absolute value there is a 1/4, so it is between 0 and 1. All right, so when we calculate it, we take our first term and divide it by 1 minus our R value, so that ends up being a negative 16/5. All right, so let's look at this one. So why is 0.3 repeating equal to 1/3? Huh, very interesting. So 0.3 repeating, what does that mean? Let's see, I'm gonna try to write it right here. So 0.3 repeating means 0.3 plus 0.03 plus 0.003 and so forth, right? All right, so what is the first term? The first term is a 0.3. And what is the R value? What am I doing each time? I'm multiplying by 0.1. And that 0.1 is between 0 and 1. So can I calculate the sum of these numbers? So that would be what? 0.3 divided by 1 minus 0.1. So this ends up being what? 0.3 is what? 3/10. And this is 1 minus a 1/10, right? Just gonna do it in fraction form here. So this will be what? 3/10 over 9/10. So that'll be what? 3/9. And 3/9 is a 1/3. All right. So do the last one for me. I'll check this tomorrow. Hopefully I'll be back tomorrow. And if you need anything, send me an email, okay?